Hi everyone, welcome back to the channel. In today's video, we are going to discuss the Karnaugh map. In that, we are a new case, that is a don't care situation. So what is meant by don't care? In the problems, how we have to solve the don't care condition if given. So with the help of SOP and POS formats as well in this video. Let's get started. So if three variable table is given, so output is according to the question. We don't know the question. So if any exam paper or any syllabus in there, we have some examples. So I took a random example. So the three variables are A, B, C. So output F1 is some random output. So this is the output. We have known this output. So we already know about SOP. In SOP, we consider only once in the min terms, and so only called min terms. So those only we will write in the K-map and we will solve to minimize them. Whereas in the POS one, we will only consider the outputs as 0 and we will write, or we will group the zeros in the K-map and we will minimize the output expression. Without using Boolean algebra, just group them and write the output expression. For a 4 variable system A, B, C, D, that is 842 and BCD. So suppose in the question paper and anywhere we have given just from 0 to 9 in decimal, so and binary as well. So we know only the output expressions from 0 to 9. We don't know the remaining terms. So the remaining term also exists from 10 to 15. So those we don't know. In binary, the output format we don't know. In those situations, so from 0 to 9, they have given the output would be 0 or 1, but we don't know the remaining ones from 10 to 15. So those or can be zeros or ones. For understanding the use of don't care, so first don't consider the don't care term, just consider the sigma notation according to the normal K-map for grouping. So blue group is A bar B bar, the green group is B bar C, the orange group is A bar C. So you can observe we have three terms with two expressions in each, two variables in each term. The unknown output for the 6 terms, so that might be x. So for the minimal expression in the SOP format, we are going to consider as x as 1 for the grouping. So for the grouping of POS form, we are going to consider x as 0, because we already know SOP means sum of product, POS means product of sum. Without any further delay, let's start with an example. So they have given this K-map. So according to the equation of the sigma notation, we have to write all the ones inside that. So we know how to write the sigma notation. So after that, they also mention plus D24. D means don't care. So we already know 0, 1, 3, 5. In the place of that, we have to fill ones. So in the places of 2 and 4, we have to place a cross mark or D mark. So this represents there we don't know output. There it can be 0 or 1. So it can, if x is used as a grouping term, so we can use that x for the grouping. So from 10 to 15 they are not given, they are not mentioned, just they have mentioned from 0 to 9. In that situation, the zeros or ones are called as don't care situations or don't care conditions. So with these all 6 terms, we are going to consider as a variable, that is as x. So x can be 0 or 1. So don't care condition can be represented with x or small d. With don't care terms included, we have to consider the don't care also as a 1, because we are first doing with SOP. So that is sum of product. So if you consider that, we can group 0, 1, 3, 2 as a group and 0, 1, 4, 5 as a group. So the blue group indicates A bar and green group indicates B bar. So see, the output expression contains only 2 terms with individual variables. So this is very expressed or very minimized as compared to previous one. So always we have to use don't cares if it is participating in the group formation. Otherwise, don't use them. Don't use only don't cares to make a group, because it's not valid. We can make groups with the help of ones. Suppose in POS, we can make groups with the help of zeros. I hope you understand the first one, that is using 3 variables. So now quickly start the second example with the help of 4 variables A, B, C, D. So they have given the sigma notation and don't care term. So as they're given it there in the question, we should fill that sigma notation terms in the K-map. So after filling that, we will fill according to that. So 5, 6, 9, 13, 15. So don't care terms are 1, 7, 14. So fill according to that x I have filled there. Now you can cleanly observe that C bar D is one of the group that is vertically, and x1 15, that is 15 and 14, that is 7, 6, 15, 14 can be made as a group, that is green. So that output would be BC, and a purple one output would be C bar D. you can observe if you don't use them, then it might be we have to make a group of 2 so it becomes very difficult. Group output expression will be large. So if you consider that is sum of product SOP format, we have got the output. In the above I have wrote already a sentence, that is, if don't cares used in the group formation, use them. Don't make groups of only don't cares. So this you will be understand in the video. So in the second example only we have saw the SOP format. So in the same example we are going to have POS, product of sum, means we have to consider the zero terms. So remove in the place of ones, just replace or remove ones, and the remaining blank places I have filled with zeros, because it resembles like that only. The remaining blank places are zero itself. So I have filled with zeros, so don't change the don't cares, because don't cares also involved there. See, these grouping can be formed without the help of the don't cares. So if formed with the help of don't cares, it's not a problem. But in this case, without don't cares only, we are finishing our job. So the first green group is C bar D bar, and second group is B bar C. So see the largest possible group. If not possible, don't take help of don't care. If possible, take the help of don't care. That's it I can say. This is POS. As this is product of sum, so we should not write that directly as output. So let us see the first expression that we can make. So f2 is equals to pi 0, 2, 3, 4, 8, 10, 11, 12. So we have to not place plus there. So dot d 1, 7, 14. So this is the expression that we can make. So as this is the SOP, not the SOP, so this is POS. So we will get output as F2 bar if we add them, that is B bar C plus C bar D bar. So if you want F2 as output, so take bar of them. So B plus C bar dot C plus D. So this is the syntax of the POS or SOP formats. Let us have a quick look over this. So they have directly given the POS format, so we have to fill the K-map using that. So I can fill all that with zeros, because we have to fill with zeros. This is POS, not the SOP. So if SOP given, we can fill with ones. So this is POS. So they have given the two don't care terms also. The first one is 2 and 4. So fill both of them as well with the X cross, don't anything. We can do D also there in place of X. See, here we are taking the help of don't care, that is in the position of 2. We can make a corner grouping, and we can make a group of 4 as that 8, 9, 11, 10, and we can make group of 4. So here we are getting three output expressions, that is of 4 elements of 3, 3. So the output expression would be F3 bar, because this is POS, not SOP. That is A B bar, B bar D plus C D. So if you want F3, so you are going to apply a whole bar over that. So by using Boolean algebra, we are going to get output expression as that A bar plus B dot B plus D plus, so dot C bar plus D bar. So this is just the representation of POS, the product of sum. In the same way, we are going to have the SOP, that is sum of product. The opposite thing we are going to get, means we have to fill the remaining things with the 1 and don't cares as it is. So we can now make groups, and we can get the min terms, and we can find out the minimum expression for this. See, in this also we can use the min term, one min term. The second min term is useless, that is in the position of 2. So the first group of blue group, that is 4, 5, 12, 13, we can make a group, and green group is possible with in 2 terms, and the 6 and 14 as a one group. So because you can observe that it is not a group of single group, that is a corner grouping, that is 4, 12, 6, 14, that is orange group, elements of 4. So that is the 3 groups that we have formed up to now. So according to normal K-map, you can minimize that according to the side rows and columns. The final output would be B C bar plus B D bar plus A bar C bar D. So at last I would like to mention a note. When I am discussing about the don't care, I also said this point indicated particularly, that don't make groups of only don't cares. So the first example is that only. So you should not make only the groups of don't cares, because we should not make that. So we can take help of don't cares, like you can see in the first K-map only 15, 14, 11, the 10. So the 4 can be made as group, but the 0, 1, 4, 5 cannot make as a group, because all are don't cares. So that's not possible. This K-map is not possible. But in the second one, you can take a help of from the don't care. So if you observe 3 2, so that's not a group of 2, that is a group of 4, because we are also mixing with 11 and 10, so that's a group of 4, so we can use that. So in the blue group also, that is 0 1 4 5, see those 2 are not as a group, so those 4 as a group, so we can take help from that. So this is the allowed one. So first one is not allowed. Don't care means nothing, we don't know, means 0 or 1, the output is we don't know. So that's it. So I hope you understood what is meant by the don't care. We saw examples also with the help of SOP and POS formats. Thanks for watching up to now.